Start recording. Okay, this is a quiz for lessons. What is this? 4.6 and 4.7. You can pause it now. Let them work on it. Okay, so here we go. You divide, right? 13 divided by 3. That's how you get it to a mixed number. 4 1/3 is the answer. Okay, number 2. What do I do to turn that mixed number into an improper fraction, Caleb? What do I do? Up here. What do I do?
How you change?
No, what do I do? I'm changing 3 7/8 into an improper fraction.
No, you multiply 3 and 8.
Times that?
And then you add 7.
Got it. Perfect. What is the answer? 31/8. Yes? 31/8. Number 3. Made it kind of easy. I made one so that if you wanted to, you could list the multiples, right? How do I find, well, for this one, what would you do to find the least common multiple? I know a lot of you say, I'll do it in my head. Yeah, but in your head, what are you doing? Are you doing prime factorization in your head? No. What are you doing in your head? Listing the multiples. The multiples of 15 are 15, 30, 45, etc. The multiples of 10 are 10, 20, 30. Oh, there they are. Agreed? The least common multiple of 15 and 10 is 30. Right? Do y'all see it? Momo, do you see it? Number 4. The least common multiple. I did one that you probably aren't going to want to list the multiples of 18. Agreed? I mean, you probably don't. I could do it, but it would take me a long time. That's not why we do this. 18 is 9 and 2, and that's 3 and 3. So 18 is 2 times 3 times 3. 40 is 2 and 20, 2 and 10, 2 and 5. So 40 is 2 times 2 times 2 times 5. Agreed? What do I do now at this point? What do I do at this point, Dylan? You see just what are the factors, right? That's what we do. We kind of see, well, what are the factors? 2s, 3s, 5s. Okay. Which one has the most 2s?
40.
Which one has the most 3s?
18.
Which one has the most 5s? Multiply everything. 2 times 2 times 2 is 8. 8 times 3 is 24. 24 times 3 is 72. 72 times 5, this is the only hard part, right? 10 is 360. The answer is 360. The only way you would have gotten that, I think, is for you to have used prime factorization. I don't think y'all wrote out the factors of 8, or the multiples of 18. Notice what I did. I did greatest common factor of the exact same two numbers, so that I could see that you understood the difference between a multiple and a factor. What are factors again? Michael, what's a factor? That goes into another number evenly. Number that goes into another number evenly. What are the factors of 18? Well, first of all, what could you do here? If you wanted to, you could do prime factorization. 40 is kind of a long one. Maybe. You might want to do that. Or what else could you do? Just list them. Which one do you want to do? I don't care. List them. Factors of 18 are 1, 2, 3, 6, 9, 18. Agreed? Factors of 40, 1, 2, 4, 5, 8, 10, 20, 40. What's the greatest common factor? 2. All right, here we go. So lesson 4.8, comparing and ordering fractions. Oh, correct your homework. Yeah, let's do that first, sorry. All right, now we're doing the next lesson, 4.8, comparing and ordering fractions. Listen, there are some things that hopefully, as an advanced math student, you kind of have down. I can generally tell the order. If I was given a list or even a couple of fractions, and I was asked which one's bigger. I can generally do it without even showing any work at all. I can just look at it and see. Do you know why? Because I can put the fraction on a number line in my head. Okay? If I have this, if I have even a big ugly one, like 13 19ths, that is not an easy fraction to put on the number line. Agreed? Right? But here's the deal. Fractions are always a part of a 1, right? It's part of, it's somewhere between 0 and 1. That's what a fraction is that it's a fraction of a whole. Right, Momo? Any fraction is a part of a whole. It's going to be somewhere between 0 and 1. When I look at 13 19ths, you look at the denominator, which is the bottom number, and you decide there's 19. If I was to break this thing up into 19 pieces, you know where I want to know, where is half? Where is approximately half of this? If there was 19 pieces, what would approximately be half of 19? Just,
Exactly half or just approximately?
which one? 9 or 10, right? It's going to be somewhere near 9 or 10. So then if I know that right here is like, 9 19ths-ish, then all of a sudden I have to look and go, okay, well, where is 13 19ths? Where would 13 19ths be, Emily? Where would 13 19ths go? Just give me a ballpark as to where it would go. To the right or left of the 9 19ths? It would go over here. This is where 13 19ths would go. Right. Obviously, it would go over here, right? Somewhere in this neighborhood. Does that make sense? Does that make sense?
Yes.
Just even knowing that that's true will help you a lot. Because what if I give you this? What if I want you to tell me which one is bigger, 13 19ths or, I don't know, 21 45ths? Two very ugly fractions. Do you agree? Two very ugly fractions. Now, a lot of people go, okay, well, 13 is smaller than 21, so obviously, which one's bigger? People go, oh, 21's bigger. Not true. Again, 13 19ths. You've got to be able to put that in perspective. You've got to be able to look at this and go, okay, 13 19ths. I know. What do I know about 13 19ths? It's more than half. That's exactly right. It's more than half. In fact, it's probably somewhere between, it's almost like 3/4. You see what I'm talking about? If you could somehow in your head get things to where you know about where a half is, 1/4 is, and 3/4 are, you're in pretty good shape. That 13 19ths is somewhere near 3/4. Do you understand what I'm saying? What about 21 45ths? What do you know is true about that? What do you know about 21 45ths? What do you know is true about that, Sladen? It's less than half, just barely. Right? It's just barely less than half, so that means it's going to be right around in there. Well, then without doing anything else, which one's bigger? 13 19ths is bigger. Does that make sense? That's with you doing it and not doing any math at all. That's just you thinking and kind of figuring it out. Does that make sense? What about something like this? What about an ugly one like this? What about like 4/5 and 5/6? Now here's the deal. Here's the deal. Which one is bigger? And I know a lot of you will know this, but I want you to be able to visualize it, right? Remember, fractions are always between 1 and 0, right? 0 and 1. They are. They're always between 0 and 1. That's what a fraction means. It's a portion, a fraction of a whole. 4/5. How many different chunks would I break this one up into for 4/5? How many chunks is there? There's 5. I'm going to break this up into 5 chunks. Agreed? That was not the best drawn. Do you agree? Where is 4/5 then? Where is 4/5? Stop clicking. Where is it? Where is it exactly? I broke it up into 5 chunks. Where is it exactly? The third one. 1, 2, 3. Right here. This is 4/5. Where's 4/5, guys?
The farthest one.
If this is 1/5, this is 2/5, this is 3/5, this is 4/5, right? Right? It's the farthest one. 4/5 is way over here. This is 4/5. 5/6. Do you agree that that is, when it comes to sixths, 5/6 is as close to 6/6 as you can get? Do you agree with that? So if I break this up into sixths, if I break this thing up into 6 chunks, is the chunks going to be bigger or smaller? Smaller. So it's going to be more like this. You agree? There's 6 of them. Where is 5/6 going to be? Where is it? Where's 5/6? It's this guy, right? He's going to be a little closer to 1. The whole. Exactly. I just want you to be able to see this. I'm trying to help your brain see this so that you aren't just trying to put numbers together and try to, I want you to see it. So then by looking at this right here, which is bigger, 4/5 or 5/6? 5/6. Which one is closer to the whole, right? When they say bigger, they're saying which one's closest to the whole. 5/6 is. Knowing that then, knowing this, let's try this. What about this? Which one is closer to the whole? Momo. 31 30-seconds is definitely closer because they're broken up into smaller pieces, right? And if it's the furthest one, you see what I'm talking about? I want you to be able to see that and understand that. All right, so that's just you kind of like, being able to kind of plot it in your head will help you a lot of the time. For example, if I said, order these from the smallest to the biggest, and I said, okay, 3 2/5, 3 3 4/5, 3 2/5. No. 3 1/3 and 3 1/2. Could you order those from smallest to biggest without doing any math at all? You should be able to. Why? Ellie, how could you possibly do all 3 of those without doing any math at all, just telling me the smallest to the biggest? I'm asking Ellie. How could you know without doing any math? Just in your head. $1 million is on the line. I bet you could do it. Oh, man. How do you do it? Shh. How do you do it? How could you tell which one is the smallest one and which one is the biggest one and which one is in the middle? How so? So tell me, what could you do? What would be your strategy for solving that? Okay. Tell me, what would you do? This is not for $1, by the way. That was for her. Jonathan, thanks for raising your hand, buddy. What is your strategy?
There's stuff, the numerator and the fourth is bigger and the fraction is broken up into.
Okay, I'm going to stop you. This is really it. Listen, if you can, remember, these are called benchmarks. What should you break up? What should you really have a good grasp of in your head? You should know for sure a half, right? You should know approximately when something is a half. You should certainly be able to tell when something is bigger than a half or smaller than a half. Do you agree?
Yes.
And if you're really good, then you'll know things that are about a fourth, right, and 3/4. Knowing that right there is usually enough for you to be able to solve any of these without even doing any math at all. What I mean by that is this. They're all 3s. So does the whole number have anything to do with this? No. 4/5. What do we know about that?
It's almost.
It's bigger than a half. Agreed? that somewhere it's over here. That it is in this region. It's bigger than a half. Agreed? What about 1/3? What do we know about that? It's less than a half. The 1/3 is going to be somewhere near less than a half. What do we know about a half? Oh, it is a half. So then, since we know that one of these is less than a half, and we know that one of them is a half, and we know that one of them is bigger than a half, can we order them from smallest to biggest? Oh. Just by looking at them and placing them in your head approximately where they might go compared to a half, you've got it. Does that make sense?
Yes.
Yes. So then, which one's the smallest one? 3 1/3. Which one's the next biggest one?
3 1/2.
Which one's the next biggest one? Did I do any math there? No, I didn't. But that's not math. That's not me doing multiplication or addition or subtraction. That's just me understanding fractions. Agreed? Do we all understand that? Okay. Here's the deal. I'm going to show you some shortcuts now. I'm going to show you some math, how to figure it out, all right? What about this? If they go like this, if they go 3/5 and 5/8. Okay. What are they asking me here? What's the question asking? Which one's bigger, right? They're simply asking which one's bigger. The reason why you kind of need to do the math here is this. They're both barely, what? They're both barely, they're both barely bigger than a half. Do you see that? They're both, that's what you should always do on these, is looking to see is one less than a half and one more than a half? Is one clearly bigger than the other? They're both a little bit bigger than a half. Oh, man, so then now we have a problem. Now we actually have to do the math. Does that make sense? If one had been a little bit less than a half and one had been a little bit more than a half, do I have to do any math? No, you just do it. They're both a little bit bigger than a half. So, okay, here's what you do. I'm going to show you the trick. Take this numerator and multiply it by that denominator. What is 5 times 5? Take this numerator and multiply it by this denominator. What is 3 times 4? Which one's bigger? 5/8 is bigger. That works every time. That works every time. The other way to do this, I'll show you the other way of doing this. It's 3/5 and 5/8. The other way is to divide them. If you divide them and put decimals, you'll find an answer. 3 divided by 5. 3 divided by 5. 5 goes into 3 how many times? 0 times. Add a decimal and a 0, bring the decimal up. 5 goes into 30 how many times? 6. So 3/5 is 0.6. Oops, 0.6. Do you agree with that? Over here, 5 divided by 8. 5 divided by 8. How many times does 8 go into 5? 0. Decimal, decimal, 0. 8 goes into 50 how many times? 6. 48. 2. Add a 0, bring it down. Oh, already I could be done because I know that this side is, am I done with 0.6? No, it's going to be more than that, right? It actually ends up being 0.625. Oh, so which is bigger, 0.6 or 0.625? Does that make sense?
Yes.
Okay. Try one. Try, it's kind of easy though. Look. 3 1/8. I would like to hope that you guys could do this without doing any math. 3 1/4. How could you do that without doing any math? How could you do it? In your brain. Well, listen. Think of the number line. They're both 3, right? So we're not dealing with that. What if one of these was like, 3 1/8 and 2 15/16? Which one's bigger? 3 1/8 because 3 is bigger than the 2, right? I mean, that's obvious. So, okay, forget that. These are both 3s. They're both 3s. So we're not dealing with that. We're dealing with 1/8 and 1/4. Can you in your brain think of 1/4 and break up the number line into 4 pieces, right? Okay, so 1/4 is that first line. If the next one is 1/8, isn't 1/8 smaller? So then all of a sudden it's broken up into 8 pieces. So then which one is bigger, 1/4 or 1/8? You really don't know, Caleb?
No, I do not.
Here's 2/4, here's 1/4, here's 3/4. Yes? Where are the eighths? In between these, right? 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. Do you all see that? Where's 1/8? Here. Where's 1/4? Here. Which one's bigger? 1/4 is bigger, right? What if, you didn't feel like going through all that? 3 1/8 and 3 1/4. What can I do? You could turn these things into what? Ignore these, and you go, okay, 4 times 1 is 4. 8 times 1 is 8. Which one's bigger?
That one.
Do you all see that?
Yes. You can times 4 to 2, it turns into 8.
Another method, let me show you this. 3 1/8 and 3 1/4 is you need to get them to have common denominators.
Yeah.
We're going to start adding fractions next chapter. I'm not going to deal with that now. That's next chapter. But here, you can multiply this 1/4 by,
2.
nope, by 1 in the form of 2/2, which is 3 1/8 and 3 2/8. Which is bigger, 3 1/8 or 3 2/8? Right? Makes sense?
Yes.
The other type of question that they ask people, is this. They'll say 2/3, 5/6, 3/4. Which one's the smallest to biggest? Well, one thing you can do is you can simply divide them. 2 divided by 3 comes out to 0.67. 5/6 comes out to 0.83. 3/4 comes out to 0.75, if you actually did divide them. Can you tell which one's smallest to biggest? What is it now? If that was the case, how would you write your answer? Would you write your answer 0.67, 0.83, 0.75? No, you would write 0.6. You'd write 2/3, 3/4, 5/6. They're asking you which of the fractions is the biggest. Right? Make sense? Okay. What up there? What of this one? 9. You do this one for me. Do that one for me. All right, Mama, what's the answer? They're equal. How do you know they're equal? Well, two things. One, what's the shortcut? What's the quick and easy shortcut? 9 times 8 is 72. 24 times 3 is 72. They're the same number. That's one. The other way of doing that would be to reduce them, right? Reduce them. What does 9/24 reduce to? Divide by 3, divide by 3. 3/8. Oh, 3/8 is equal to 3/8. If they are equal, what will be true? If they are equal, what will be true? They will reduce to the same fraction, right? If they're equal, they will reduce to the same fraction. Indeed, that's right. Your homework. I know, it's Halloween. It's a bummer. Oh, but you have all weekend, right? That's right. I'm not. What am I worried about? That's right. I also know that this, again, is a review for you